Hello everyone and welcome to another AP Computer Science video. In this video we're continuing our learning about the creation of classes, particularly data classes that represent things, and the example we've been following was our idea of creating a bank account or a class or a blueprint that represents what a bank account in a bank might be. What we've seen so far has been the creation of instance variables, how data in a class is going to be held. And these are basically variable declarations, but with the added access modifier private. And this protects the data from being used. And in this video, we're going to see kind of the example of how we can prove that this is the case. We've also seen constructors, and so if we're going to be making objects from blueprints, so from the classes, then we need to have a way to build them or find the RAM to build them. And this is what constructors do for us. They're a very special set of methods that all classes can have. And we're going to continue with proof of the constructor's abilities to work and the private variables protection, and then we'll finish up our class with some methods to clarify how we can give access to this data in a safe and effective manner. So we're going to go ahead and make a new class temporarily. So we don't have enough to at least protect or test some of these ideas, and so we're going to make a new class in our class design package, and we're going to call it bank account tester. It's never a bad idea to, as you write a class that's supposed to represent something, test out pieces of it at a time, because we can write tons and tons of code and then it might all be wrong or have some bug that is not obvious. So if we do it a little bit at a time and then test and then add some more and then test, we can limit or mitigate how much work we have to do in the future for corrections. So our bank account tester is going to be a main class. So it's going to have a main method and it's going to build some of these objects. The idea is that we should hopefully be able to test how this stuff works. So let's go ahead and make our main method real quick. And there it is. So in our main method, typically what we do is we'd make some variables, and we'd maybe make primitive variables. Maybe we'd make a scanner, which is not a primitive, it's an object, or a string, which is also not a primitive. And so now the big picture here is we made a class called bank account. In essence, what we've done when we make a data class is we've made a new data type. This is a big deal. It hides some of those details. We're abstracting away from money and doubles and strings and stuff like that for a bank account to just a bank account, whatever that entails. And again, knowing the class is what gives us the details of what it entails to be a bank account. And that can be very complex or very simple depending on how much code we write. So to create objects that are based on non-primitives, we're going to call their constructors. But first we must declare variables to hold these objects. And so we can go ahead and say creating objects from class descriptions requires two things. One, the new keyword, which we've used when we made scanners, which is how we know that this is kind of scanners we're using constructors. And of course, two, a constructor, the class constructor. Right, we have to have at least one version available to us in order to make this happen. And so, declaring a variable, let's go ahead and declare a variable type bank account. So it's very much like a primitive type, except that it has more details hidden behind it. So we'll say bank account. That's the type, so we must give the variable a name. And so let's call our first account ACCT1. And so there's a declaration. Notice there's no error. And because they're in the same package, they see each other. So as we build more classes and we make different packages, we may have to import them because they're not in the same area. But it's so kind of like scanner, which since the scanner is an important part of Java, but it is not directly accessible, we must import it to have a connection. But because these classes are next to each other in the same package, that's not really necessary here. They can see each other and use one another as they see fit. And so there's a declaration. I do want to point out something technical, and this is an important idea, and it's one of those things that Java tries to hide from us, but we do have to kind of be aware of it. It's going to come back and haunt us in a potentially dangerous way. So I'm going to mention it now briefly. That when we deal with non-primitive types, so basically anything that's not an int, a double, a boolean, or a char, or any of the other variations on those, what we're storing in the variable is not the content directly. It is a memory address to the location in RAM where that content is stored. And I know that's a really kind of weird idea, but the idea is that it's like having an address book, right? If I know where something is, it's essentially as having the access to the thing itself. So imagine if I have, let's say, some money hidden away in a drawer in my house, and I'm not at my house, I still have access to that money because I know how to get to the house where it is. So if I have an address book and I give it to someone else, they can also potentially have access to that money because they can follow the address. And so in our analogy, what we're saying is this variable ACCT1 doesn't hold the money itself. It doesn't hold the content of the bank account directly. Those variables, what it does is it gives us the address in RAM where we can go to it and then see the balance and see the account holder and all that other information. So it's kind of like a reference or indirect connection or address. You hear the word reference a lot. We'll come back to this idea later on, but we should just be aware that we're not holding simple data directly in these variables, and this is an important distinction to make, and we will see it come back. So we've declared a variable. Now let's give it a value. Let's initialize a value. And again, with an integer, it would be easy as giving it a literal value, x equals 7, or a double, b equals 22.5. But here, because this is not simple data, we must construct an object of this type, and so we must call the constructor. So we're going to say account1 is equal to a new, so there's our new keyword. This new keyword is essentially the first half saying, hey, compiler, can you find the RAM for this stuff, whatever that is? And so how does it know what stuff to find and how much space it needs? Based on the constructor definition. So our constructor is always the name of the class, so this is very convenient, so we know it immediately, it's bank account. And then we have two versions. So I'm going to use the first version, the default constructor. We chose to make a default constructor that accepted no input, so it makes some assumptions. It says, well, account 1 has a balance of 0, and it has a account holder of generic person, and a bank name of generic bank, or whatever we called it. So the idea is that this is in fact filling in the variables internally, and we can access them at some point in the future and see the content, or maybe change it or do what we like with it. So this was 2 lines, a declaration and an initialization. Let's do it in 1 line, because just like with primitives, we can say int x equals 5 immediately. We can do the same thing with our objects. We can create a variable of a complex type, or a class type if you want to call it that, and initialize it to a object directly with the constructor. So let's make a second bank account. And we can say ACCT2 equals a new bank account. And what I want to do is I want to initialize the value to something non-default. So I want to give it a balance, a starting balance, and a name of the holder and the name of the bank. So our bank account will start with 1,000. I don't have to put the 0.00, but just to kind of give away that it is in fact money, we'll put that amount. We need to give the account holder, and so let's go ahead and say that's our account holder's name, and then we have our bank name, and so we want to put another string as our bank name. And there it is. We have our double and 2 strings. And again, how do I know the order? I know it because I've written the class myself, and you will write the classes yourselves as you develop content. But if you didn't, if you had to use someone else's code, for example, you would probably have some kind of documentation. So for example, how did I know that scanners use system.in as an input? Because I've seen the API online, and we can read about every constructor. And now here we can kind of look back and see there's so much detail available online in the Java libraries and API, because we can see, well, which constructors are available, what are their inputs, what is their output, what kind of content is available. It's kind of never-ending supply of information, so we can do the same thing ourselves if we need to. We're not going to because we have access directly, but eventually we might have to write some of those details for other people to use. So right now at this point I have 2 bank accounts. What I would like to do is print out their current balances in a nice simple way. So let's try that, and I'm going to do it on purpose, and it's going to break because I want to prove that that security feature, that private access modifier, is important to us and does its job. So let's do a print message, and let's say something like account1 balance, and let's attach that to, and so normally we would have access to a variable, let's say by saying object.variable name, just like we say object.method, right? So we might have said kb.nextInt. And so in our case, our objects are ACCT1 and ACCT2. And so I might say account1 dot, and again, NetBeans will try to be smart and give us options. I'm just going to ignore them, and I'm going to just go and outright and say, I know it's called the balance, so let's do that. And let's copy this and do the same thing for 2. And notice it took a moment, but there are the errors and they pop up. And if I hover over them and read that error, balance has private access and bank account. It says you cannot access this. You may know that it exists, but you have no right. This class, bank account tester, has no right to look at that data directly. And that's a serious protection for us in this scenario. And so with that said, we can try to adjust our code to make this available, because we kind of want both scenarios. We want the protection that private gives us, but we also want to have some way of letting them see the information. They should be able to know the balance without hurting it or endangering its value. And so how do we do this? We're going to go back to our class and we're going to describe the next portion of things that are available to us in a class that we can write for ourselves. So this is not going to work until we make some adjustments. So back in our bank account, this is our blueprint. We're back to our blueprint. We know our data. We know how to construct one of these things, and we can always add more. And now we want to do is add some methods. And so methods are just like static methods, except here they won't be static because, and remember, static, when we added it, basically what we were saying was the method itself was the only context, the input and the output. Here the context is, well, the object calling it and what data it may or may not have. So it's more than just the input. If a method has input, that's important context, but so is the object that's calling it. And so there's no balance if there is no object. There is no holder if there is no object. And so it's important that we recognize. And we'll do some more examples in the future about static methods as opposed to non-static methods. But when we're describing a class, almost always we make a method that is not static. So now what we're going to do is we're going to just for the sake of being aware of the differences, we're going to categorize some of the methods that we write now into 2 broad categories. And we'll call them accessors and mutators. Accessors, their only real purpose is to give us a copy of the content of instance variables. So let's go ahead and write that. So let's say accessor methods return copies of the values inside of an object's instance variables. The standard is for the naming convention, the standard is we add the word get in front of a variable name. So if our variable is called balance, right, then we would call our method get balance. And if our variable is called bank name, we would make a method called get bank name. It's not a strict requirement, and we'll see that once we talk about this general idea, it's not something that has to be enforceable. It's a good idea to understand why we might have accessors to retrieve copies of data. But the naming is more of like a standard, and on the AP exam, they're not picky. Their code may show accessors with this typical standard, but you don't necessarily have to write that. Some questions they'll ask you to make your own name. Sometimes they'll tell you the name of the method they want you to write, and sometimes they give you accessors, and we just need to be comfortable with the idea of methods that return copies of the content. So we say naming convention is get variable name. Right? And again, the variable name is whatever it is. Also, typically, accessor methods do not have parameters. And the reason is, well, if we have access to the content already because we're in the class, do we need extra information from the user of the method to tell us what to get? And the answer is typically no. I have access to the balance. I don't need the user telling me, hey, give me the balance, except by calling the method. So often accessors do not have input. Sometimes they do, and it really depends on what your content and your data is. But typically, accessors do not have parameters to them. So this method is going to be pretty easy to do. So let's try one of these. And so let's make a method that gives us a copy of the balance. And what's nice is that because we get a copy, they can look at the number, they can mess with the number, and it does not hurt the internal balance of the object. So if I have $1,000 in my account and you get a copy of that 1,000, you can change the number all you want, but you did not change the actual balance of the object, and that's a powerful protection. So we're going to make our method public because, again, if we're going to make a method in this case, we want people to use it. We want them to be able to access the balance, and so it's public as an access modifier. Our return type is going to be the type of the data. So since I'm returning the balance, double would be an appropriate type. And then I'm going to follow the naming convention get balance. And notice there's a parameter list, but it is empty because there is no need for extra information. And this is as simple as a one-liner. Retrieve or return the content in balance. So we say return balance. And again, remember, when you return values or variables in methods, you're returning copies of the content. Now, again, we're going to come back to this idea of references when it comes to objects, and we'll say that even then we're returning a copy of a reference, so that's still a copy. Here we're returning the copy of the raw content of the number itself, so the balance is not really touched. Only the copy of the balance is returned. So that's it's a good protection. And we could do this very easily for the other two methods. So before I write them, pause the video, give yourself a moment, and write them yourself. Access modifier, return type, name, parameters if any, and then the implementation. So for accessors, it's really, really easy to do. So try that out, and then we'll come back and we will implement these methods quickly. So pause the video and try that. So hopefully you've done this, and we can write these out together now. We're going to say public because we want someone to use our accessor. For the account holder, it is a string that is the name, and we're going to say get account holder. There is no parameter because we don't need any extra information in order to retrieve the name. We have access directly. We will return account holder. And then finally, the same thing for the last one. This is also very easy. A string because we're getting the name of the bank, and we'll say get bank name. Notice I'm still using camel case as the standard because that is a typical method standard is camel case. And I'm using the word get in front of my accessors. No parameters because we don't need extra information. And we're simply returning a copy of the bank name. And so there are our accessors. So now I'm going to save this class, and let's go ahead and try calling these methods. So now that we have these accessors, we don't have this fear or mistake of trying to access the variables directly. We will go through these methods, and we will get copies, and that way we're not screwing things up. So let's go back to our tester, bank account tester, and here we are. And so instead of trying to access the the variable directly, we will call the accessor, get balance, and returns a double. And notice there is no longer an error, get balance. And there is no error. And again, remember, I could have stored these in variables temporarily and then printed the variables. That's okay, but you can put them directly because these methods must return a value before the print can occur, so they're going to be evaluated. So if I run this, I expect to see account 1 balance 0, account 2 balance 1000, because these are two separate accounts. One was initialized with default values, 0 being the balance, and the second one was initialized or constructed with the $1,000. So let's run it and let's see what happens. That should be compiling, and then we should see in a moment our output. And there it is, 0 and 1000. That's what we expected to see. So this is good. And so the idea is that I could do the same thing with the name and so on, right? So I can say account holder's information, and I could do that. And so we'll maybe do some methods that print that out. But for now, this is a convenient way of setting things up. So let's go ahead and finish this up. So our second category of methods, and again, these are all still just methods, but we categorize them just to have a sense of what they do. I said we're called mutators, and hopefully you know what the word mutate means, but if you don't, it means to change in some way, right? Mutations are things in like genetics. A mutation may be caused by radiation or evolution or just a fluke, and a mutation is not necessarily good or bad, it's just a change. And so in our situation, mutator methods, their only purpose is to change values. If accessors give us content, copies of the content, mutators change the value. So these are the dangerous methods. These are the methods that could manipulate the values. But the reason these are good is because we can write our own code to make the changes happen in the way we see fit. And so we'll go ahead and try that in a moment. So we'll say mutator methods typically change the values inside of an object's instance variables. And we'll say the standard naming convention is that if we call an accessor get something, get variable name, mutators are typically called set something. So you also might hear the words getters and setters. They're basically the collection of methods that access content and change content. And so we don't always have to have an accessor and mutator for every single value or instance variable, but that's a very common kind of thing to have happen. And so we'll say the naming convention is set variable name. Right? And so let's go ahead and make a mutator for our balance. Right? So we'll say Public because we want it to be accessible. We want people to be able to change the value potentially. And now another common situation for mutators is that they do not return values. They change something internally and then stop. And so often, it's not always required, and there is no official rule, but it is a pretty common thing to have happen. Mutators are void methods. They do not return content, so there is no return statement. So we can say void is our return type, and then let's say set balance. And now, again, because they don't return anything, they do need some kind of input, because if you ask yourself, well, if I'm going to change the balance, do I need extra information besides the current balance to do the work effectively? And the answer is yes. What am I changing the balance to? So we need to be told, hey, I'm changing your balance and I'm changing it to this value. So we typically need input. Not all the time, but most mutators need input in order to effectively change the value. So we'll say double, we'll call it changed val. And then we'll put our body. Notice there's no error immediately because there is no return requirement, but we do want to change something, so this is also a simple one-liner. We will say the old balance is equal to the changed balance. So we can say balance is equal to changed val. And then now we could do the exact same thing for our mutators for our strings account holder and get bank name. So I'm going to go ahead and give you a moment, pause the video, make them yourself, and then come back. And we should be able to write these methods pretty quickly. So hopefully you've done that. We can say public void set account holder. And we'll say string because we're given a name, and so we'll call it, I'll just call it HLD for the new holder. HLDR, maybe is a good name. And then we'll say, oops. We'll say, you know what, our account holder name is equal to whatever they just gave us. You know what, I don't know what content it is, but I'm changing it, I'm mutating my value. And the last one will be very similar. We'll say public void set bank name, and we'll say, well, give me the bank name, and I will change it. So bank name is equal to whatever they told us. Right, so again, they mutate, the standard is using the word set, but that's not always the case. And so let's go ahead and go to our tester and prove one of these works. I'm going to use set balance, it's convenient. So we printed out the initial balances. We saw that the output was 0 and 1000. Let's go ahead and call one of these mutators. And because they're void, we're not going to assign the value because there is no return value. So we just call the method. And so we can say count1.setBalance. And notice it tries to give me a default value. NetBeans is being smart and says, hey, you need a double. Here's a default value. It gave me 0, but let's change it to 500. And so let's see what happens. And so I'm going to copy and paste these two prints, and let's print them after the change. And let's run it again and see what happens. We should see, hopefully, the initial balances, 0 and 1000, and then because we've mutated internally the balance of account 1, it's 500. We called get balance. This is the same object. It's still account 1 and account 2. But internally, we've changed it because our mutator allowed us to do that. Now, again, you might say right now, this is pointless. We've done this. We could have just changed the variable name, and you're not wrong. But what we're going to do now is we'll make two final methods that are kind of powerful in that we're going to be able to write extra code to protect ourselves. And so setting the balance is okay, but that's not realistic to a bank account. Usually what people do is they deposit money and withdraw money. So let's make methods that represent that interaction. That's a much more realistic scenario. And of course, there are dangers in depositing, withdrawing money, so we should handle those things gracefully. So let's go back. And again, the reason I'm going to do these finally, one last point, is I want to make it clear that even though we've categorized accessors and mutators and methods can fall into one or the other, the reality is there is no hard rule that says you must be one or the other. Sometimes methods take input and change values and then return a value. Sometimes variables take no input and they change a value. Sometimes, not variables, but methods. Sometimes methods accept input and don't return anything. They just manipulate something. Sometimes methods take no input and then they change a value and then return it. There's all kinds of mixing and matching. There's no definitive splitting. The categorization, the talk of mutators and accessors is purely as a conceptual idea, just to have a sense of sometimes we change content, sometimes we view content, and we should be comfortable with methods that do both. So let's go ahead and make our withdrawal method. So this one we're going to make public because we do want people to use withdrawal. Withdrawal will not return anything. It's going to just change the amount of money in the account. Because theoretically, if this method existed in a real system, it might also send a trigger somewhere to a machine to transfer money to another account or to spit out cash bills to the ATM or whatever it happens to be. So we're not going to have a return type. We're going to say void. We're going to say withdrawal. And so often methods that do something, we use verbs as names. So withdraw is a verb, right? To take out something. And in this case, we also need input. How much money are we withdrawing? So let's say double AMT for amount. Now ask yourself, what dangerous things could happen when withdrawing money? If someone called our method, what could they do either on accident or on purpose that could mess up the withdrawal, where the default withdrawal action is the removal or lowering of the amount of the balance? There are two scenarios that I'm concerned about. So give yourself a moment, think about it, and then we can mention what these things are. So hopefully you've thought about this, and if you didn't pause the video, maybe it's a good time to pause now and then think about these two dangers before I say them. The first one, hopefully we've recognized, and hopefully no one ever has to deal with this situation, but it is a real situation, is the attempt of withdrawing money that you do not have. If I have $73 in my account and I try to withdraw $100, that's a problem. Now, and again, in a real system, maybe some banks, what they do is they lend you the money and then they charge you a fee, or they warn you, or they send a text message or something like that. In ours, what we're going to do is we're going to print a message and then not do any withdrawing. We're just going to kind of move on. So let's ask ourselves, right? Do we have enough money? So if the amount that they're trying to withdraw is more than the amount we have available to us, the balance, then we should print out an error message. And so we'll say insufficient funds, no withdrawal. Right, so there it is. So no withdrawal occurred, we'll put ... Because again, they couldn't withdraw what they didn't have. What is the second scenario that's a problem? And this one is maybe even more subtle and weird, and we would hope it would never happen, but it is a real possibility in our code because it's a logical error, a semantic error, not a syntactic error. And this problem is, what happens if they try to withdraw a negative amount? If I have $47 and I withdraw negative $40, then I'm going to end up with $87. Because withdrawal would imply subtraction. Subtracting a negative is adding a number. And therefore, if they snuck in a negative amount, they could cheat our system and give themselves money. We don't want that happening, right? So let's ask that question. If the amount that they gave us is negative, i.e. less than 0, then let's complain invalid withdrawal amount. No withdrawal occurred. Right? And then now, the last scenario is the safe and correct one. If they did not give us, if they did not take out or try to take out more than they had, and they did not give us a negative amount to withdraw, then we can safely take away the money. Our balance, we subtract, and I'm going to do it the long way, is equal to balance minus AMT. We could always say minus equals, but that's the same thing. And there it is. And let's finish up this video with our deposit. Well, actually, we're going to test them, but this is the last code we're going to write for our bank account class. And it's a very similar scenario. We want everyone to use it. We're not going to just return anything. We're just going to do the work of depositing the money. We'll call it deposit. We need to know how much money they're giving us to deposit. And then now here, there's only one danger, and this is essentially the same as before. If they somehow sneak in depositing negative money, they would lose money, which doesn't make sense. You shouldn't be depositing and losing money, right? So we should check for that case specifically. If our amount is less than 0, we can do something like invalid deposit amount, no deposit And there it is. And otherwise, they've given us a positive number. And we could say less than or equal to 0, because if they try to deposit $0, it's not dangerous, but it's weird. So we probably shouldn't do it. We should just say, well, why are you trying to deposit money that you don't actually deposit? That's not helpful. And we'll say else our balance is increased by whatever amount they did. So here I did it in the shorthand. So there's our method. So let's go ahead and test this and prove that some of these things happen. So we should aim to deposit a negative amount. We should aim to deposit a positive amount. We should aim to withdraw more than we have. We should aim to withdraw a negative amount and then withdraw a correct amount. And we should see some of these errors happen, and hopefully our math will be correct. So let's finish this strong. We will say our first account, let's try to withdraw more than we have. So how much do we have in our first account? We had 0 initially when we constructed it. We set it to 500, and now let's try to withdraw $1,000. That should cause a problem and then do no withdrawal at all. Then we should maybe try to take some money from our second account correctly. They have $1,000 to start with. Let's go ahead and withdraw $250. Let's try to deposit $250 into our first account. So now we should have $750 and $750, right? Because we've taken away from here and we've added from here, so that should put them in the middle. Let's try to deposit a negative amount. So we'll say account 1.deposit negative 100. That should fail because we can't deposit negative amounts. Ooh, I missed the T. Let's go ahead and try to withdraw a negative amount. So let's do account 2.withdraw. And there it is. And now let's do one last thing. Let's try to withdraw half of the money in account 2. So I'm being vague on purpose. I could figure out the math and say how much is in each one and then calculate that number and then put the number, but I want to use only methods or variables or whatever. I do not want to use exact numbers. So I want to withdraw half of the amount in account 2 from account 2. So pause the video, think about it, and write maybe a couple lines that will do that for us. So hopefully you've paused the video, you figured it out. Let's try doing this. I'm going to do it with a variable just to make this a little bit easier to read, and we're going to say, well, half of the account 2's money should be account 2, the current balance, which I can get with the method getBalance, and divide it by 2. And then I'm going to withdraw it. So I'm going to say account 2.withdraw half. Right? I don't need to know the numbers for this to be correct. Whatever the number is, I'm going to withdraw. Now, if it happened to be 0, then it'll still be okay because 0 divided by 2 is 0. And then withdrawing 0 won't hurt anything, right? We didn't even consider that case in our code. We didn't say if it's equal to 0. We said if it's bigger than the amount or if it's less than 0. But if they withdraw 0, so we should maybe make this inclusive, just so that they can't withdraw $0. Again, it wouldn't hurt anything, but it would be maybe strange. So here we go. Let's run this and see what happens. And then, of course, we should print our balances. And so before we run it and print it, we should kind of have a comforting idea of what's in them already. So I believe at this point, they were both 750. These do nothing because they fail because they're mistakes. And then half of 750 will be withdrawn, so we should expect account 1 to be a little bit bigger than account 2, basically double the size. So let's see what happens. We should, I believe, be 375, so let's run it and see. And there it is. The initial balances, 0 and 1,000, our setting of the balance to 500. We failed to withdraw because we didn't have enough money. We failed to deposit so we did a withdrawal and it worked just fine. Where are we at? I'm sorry, let me find my code. We failed to withdraw because it was insufficient funds, right? We withdrew $250. That didn't show up at all, and that's fine. That worked. We deposited $250. That no problem. We tried to deposit negative. That's an invalid deposit amount. We tried to withdraw a negative, which also was a mistake, and then we printed the content. We took off half, so half of 750 was 375, and there it is. And so 750 minus 375 is 375. So this is the result. And again, you might say, well, a lot of this was not, we could have done all this code inside of the main. And the answer is we could have. But if I were to give you the scenario of we're going to have hundreds and hundreds of accounts being loaded into our system, and everyone has a balance and a method, are we going to write the same code again and again hundreds of times? No. And we can use a loop, and we're not there just yet, but we'll be able to collect multiple items in under one variable at some point, and we'll be able to loop through them all instead of having to write all this code a bunch of times. We might maybe read it from a text file and do a withdrawal and deposit and a withdrawal and a deposit, or we might read it from a database online, or a live web page where they log in and they do a bunch of work, right? When you do your online banking. The point is the system is flexible because we can make banks accounts whenever we feel like, because they're from a blueprint without having to make variables. But we can't dynamically make variables. That's the problem. But we can dynamically, with this new keyword and constructors, make objects while the program is running. That's a big, big deal. So our video is going to stop here. We're going to do some more examples in a future video, and you will have a project very soon that will have you making constructors and methods and hopefully getting comfortable with the idea of planning out classes, these blueprints to be used for complex systems. I'll see you in the next video.